I don't know if you saw, but rather than being like this, it started to really droop like this, which is very dangerous because if it's not bending in the right direction, if it's like this, you get progressive creep. The whole shape would continue to become weaker and weaker as it deforms. So we were paranoid about that happening. And the way we tried to resolve it here was first releasing the middle part from the scaffolding while resting the 3 forearms of the structure, if you must, on the steel scaffolding, so that we would first have the top set and we would push it out in the right direction. And then it would only become stronger and stronger as it deformed. So when we released it from the scaffolding, nothing happened. It didn't move a bit. It was totally stable. We took it off the metal scaffolding and nothing happened. So then we had to start preparing for the fabric. Here you see them chiseling off or cutting off the sharp corners. And then we were running into this problem. It was the hottest day that summer that we had in 130 years. And the problem was that this bamboo was fully exposed to the sun. And the top was so hot that you couldn't put your hands on it, while the bottom was still nice, cold, and cool. So as you were walking on the construction site, you'd constantly hear tack, tack, tack. And every tack was one bamboo splitting somewhere. So we sat down with structural engineers and they told us that according to their models, if we would randomly cut 30% of the bamboo poles, it would still be stable because of its hyperstatic nature. But we still wanted to play safe, so we replaced every pole that had a crack of more than 1.5 meters. So it was easily done. We just cut the wires, bring in a new pole, don't need to mark up anything, and just tie it up and the whole thing stood. So we had to do that up until the whole structure was completed. Then the fabric. 910 square meters, 450 kilograms. Normally you'd very easily be able to use your digital models to just unroll strips of fabric, use a CNC cutter to cut them and put them back up. The problem was that we didn't know how close our digital model resembled to physical reality, and that we needed to have a close fit, otherwise the wind force was not transferred properly. So the way we solved that problem was with this. I don't know if you know this software, Pepakura.
Yeah.
It's a really fun software. You can make all your 3D toys with that. It's basically unrolling whatever shape you want into a laser cut file that you can then use to make your stormtrooper helmet. We used that, but the other way around. We found out that on site everybody had a smartphone, as you all probably do as well. So what we did is we set up a shared Google Doc, and we had all of the guys manually first mark up the triangle points of the fabric, and then manually measure them and punch those numbers into a shared Google Doc, where we had everything nicely numbered. And with that spreadsheet of data that was quickly generated in group by these different people, in 3 days we managed to get the unrolled developable parts of the fabric. And doing a 3D scan of the structure, which would have been the logical suggestion probably, would have been absolutely impossible because of the complexity of the point cloud you would get from a structure that's standing on top of the scaffolding. So this reverse engineering worked quite well. We made a physical paper model of it that identified that in the areas of free hanging members they didn't follow our guidelines. So this became again a construction document to talk with them. Anyway, that setup worked. Then we went to Shenzhen, where there was this factory that was making circus tents. And in that factory you had the largest CNC cutter I've ever seen, like a 12, 15 meter long table with a little suction bed at the bottom, and then this cutter wheel that goes across, operated with some hacked version of AutoCAD 2007 or something. Worked totally fine. So all they did is they unrolled this glass fiber fabric over it, the laser cutter would go over it, and you have all these triangles. They numbered all of them manually, and then the clever thing here was that there was again a self-correcting property of this fabric. Like, we were worried about them mixing up triangles, but the way the seams were made is that you get 2 triangles with exactly the same edge, you put them next to each other, and then you use another thin strip, like 8 centimeters wide, that you glue over the edge with super glue. And if your edges are not the same length, then you know you're doing something wrong. And then that edge gets fused into the fabric. So here you see this welding machine that basically heats up and melts these plastics together. So basically, all of these 1,200 triangles were turned into one gigantic sock that was then brought to site. That's the whole sock, weighs 450 kilos. And that thing was hoisted onto our structure. as they're doing it here, as they're unrolling the thing, I'm talking downstairs with the guy, I'm like, you know, this is a triangular structure, but it's not equilateral. Like, there's a long leg and a short leg. How did you position the fabric? And they were like, well, that's the longest leg of the structure, and we put the longest leg of the fabric there. I said, okay, what's the longest leg of the fabric? Well, the longest leg of the fabric, the longest one. I said, okay, where did you start measuring? Well, from the middle. Well, where's the middle? And they're like, go away. So they pushed me away, refusing to tell where the middle was. So as they're unrolling this thing, I don't know if you see already, basically here, too much fabric, and here we're way short. So on one end, this looks like it's spanning, like, I don't know, its pants have shrunk, and on the other end, we have too much fabric, which is a huge problem, because this is the equivalent of having a nylon stocking draped over a rose bush. You cannot just pull it off, hoping that you're not going to just tear the fabric into pieces. So this was a huge problem. I don't know if you've seen how the clouds were slowly packing in. The problem only became worse when a black rainstorm arrives an hour later. And the black rainstorm means 7 centimeters of water per square meter per hour, which is bad enough if you're on a flat surface. But if you're on a curved surface, then you have areas where water converges. And this fabric was not put under tension, so in the whole top area, we're having these massive pockets that were created. So all of a sudden, this happened. So in one of these areas, the rain was converging, and it was starting to pull the fabric in. But one of these edges is around 1.5 to 2 meters. So this is basically 2 cubic meters of water that's hanging there. And 2 cubic meters, that's 2 tons. That's a big Mercedes hanging from one triangle in our structure. So we were freaking out. We were running in there trying to push out the fabric. And in the meantime, the contractor saw this happening, and they ran up with a bunch of guys with knives, and they just started like stabbing at the structure to get the water out. As you can see it pouring out there. To prevent it from really sucking down and destroying the whole structure. So we managed to save it a little bit. We had a bit of damage. In certain areas, the fabric was torn. So the best thing we could find was to temporarily use whatever we could find to just prop up the fabric so that it wouldn't converge anymore. That's why we have this weird war memorial photo here. Those are the lips to fix the fabric. Anyway, bad day, difficult construction site. Discussion. So then the next day, we had to take off the fabric. They were a little bit more open to our suggestions now. So we sat down with them, decided where the wind was coming from, and then together we slowly rolled up the fabric, not like the rose bush pulling, but rolled up the fabric. And worked quite well. So here you see us around lunchtime. The first part had been rolled up, fixed to the crane, so it's nice and safe. Everybody broke for lunch. And then good spirits, some guys came back early and decided to do everybody a favor and start with the rolling up of the second leg. One problem was they didn't check the wind, and the wind had slowly turned. So here you see the wind catching into the fabric, bigger and bigger and bigger. And we're right next to, I don't know, 4-lane roads all around it, and our GoPros didn't catch the exact moment because they were on a 30-second interval, but at one point, the whole fabric took off, was held only by one point at the crane. And if it wasn't for that, it would have been gone onto the highway there. It took off and it crashed down onto the structure, impaling itself onto the scaffolding there, sliding down, I don't know why he's still smiling, sliding down on the ground, saving us half a day of work, but further damaging the structure. So again, a tough construction site. But we spent the rest of the day fixing the fabric. My guys now carefully measured which one was the long leg, and then the next day we hoisted up the fabric again, and now we managed to perfectly drape it, and the whole thing perfectly fit. Thank God, because the next day, Typhoon Mujigai was coming. So we were under extreme stress to get this thing down. Typhoons were our biggest worry. And so we in a panic used whatever we could to really pull the fabric down as much as possible. There were some ropes going over it because, as I mentioned, if the fabric is not connected to the bamboo everywhere, the whole thing can just tear to shreds. This is quasi-timed. This is a photo that the structural engineer sent to me around midnight, and it's never good if your structural engineer is on site at midnight. But luckily, the typhoon was a very mild one. It kind of missed Hong Kong, and we didn't have any damage. The whole thing survived. So here you see them the next day, fixing all the connections of the fabric. and all of the connection points. We replaced these temporary placeholders with the actual turnbuckles that we needed to get a nice continuous seam, finished everything off with fabric, and then the scaffolding was removed. So for the first time, we could see the structure in its beautiful simplicity. Kind of weird to see it so obvious and straightforward, with none of that war story behind it. But it's very elegant. The last thing that we need to do is fix all the edges here, close the seams up, make doors in it for entry, and then, I don't know if you can see it here, there's a metal wire that goes around it, which are these suspension points where we're pulling it up to the top. Then we installed some lights in there, LED lights, very simple, very powerful, using the shield as an uplight reflector to make a very calm atmosphere underneath it. This is me and my bamboo specialist in the structure. It's an amazing structure for parkour, really fun to climb through. We had to lock the doors with padlocks so that people wouldn't climb in and just climb all around it. But just to give you a sense of scale of how big this thing is when you're looking at it over here, it's really big. And here you see the finished structure. So this is the context. A nice little green park. These are the big roads I was talking about. It's actually six lanes, I think. Anyway, all these big high-rises around it. And what we wanted to do is really create a quiet space where the structure itself almost becomes a shield for this aggressive architecture around it. A shield that blocks all the lights from the surrounding, but still has arches that are high enough for the park to come in and create this more horizontal orientation rather than this upward orientation to all the commercial architecture around it. Here you see, this is the opening night. Here you see the first student study model and then the later study models that we did. So the student model and the ones that we did later on. Yeah, where you see the whole structure. This is a view from below, where you see the procedural logic embedded in a triangular structure here, going into quad shapes at the area where the surfaces overlap, and have the single free spanning members over here. And they use it for 9 months after that for all kinds of weird zero carbon events. If you don't know what a zero carbon or low carbon Christmas party is, that's what that is. So they've been using it for all kinds of public events since. We did a 3D scan of the structure, and this time we saw a larger deviation. In 2 areas we were over a meter, and we didn't really know why that was. I thought for a second that that Mercedes-Benz hanging from it was maybe the reason, but that happened over here, so that cannot really be it. What we think is that in these 2 areas, 2 of the 3 directions are almost straight, and we think that the bamboo just snapped into its original straight position, with the 3rd direction not having enough curvature at play to really pop it into shape. But what the good news was here is that the synclasticity of the whole structure was kept, so everything was bending in the right direction, meaning that progressive creep would not cause into increased deformation, so it was safe. We did have to take the structure down because the site didn't allow for it. This is self-cleaning fabric in Hong Kong, for the record, so that's how dirty it gets even with the self-cleaning fabric, with the polluted air that we have there. And this is the bamboo, that's the bamboo itself being removed. So notice how the poles still straighten up whenever they're released. So you see that the bending force was still part of it. They all became straight members again, or as straight as they were at the beginning, meaning that the bending force remained active until the very end. This is a structure without the skin, where you can see how thin this is for the span that we're working at. And these are some shots of the finished project. So before I show you the very last project as a final tease, your washing machine has more power than they used to put men on the moon. What are you going to do with it? It's for free. In India, they recently released a smartphone for 29 Hong Kong dollars, which is 100 Taiwanese dollars. Absolutely nothing. But Gibson was right. The future is already here. It's just very unevenly distributed. And we need to find ways to engage in a strategic conversation in areas where you don't have the high tech available that you would have access to if you're working for a company like, for example, Architects. But it's up to the architect to be take the role of the fusionist, the person that brings all of these groups together. This is a concept from Asta Roseway, where she's saying that digital technology used to be chunky. It's like ice, very hard, cold, and difficult to break through. Then it became liquid, became more easily accessible, but nowadays it's like vapor. It's around us everywhere, and we don't even realize it. The architect is a person that is in the best position to reclaim the ground that he may have lost to professions like facade consultants or things like that, to regain that conversation and that dialogue with craftsmen and builders. So to end up, final project, I don't have official client permission to show it because the project actually went wrong. So I'm not going to tell you which coffee company this was for.